Hi, this is Kumaravil, Assistant Professor ECE from RMD Engineering College. Today's topic we are going to discuss about microwave circulator. Okay, microwave circulator is a multi-port waveguide junction in which wave can flow only from nth port to n plus 1 port. So now let us consider 4-port circulator, right? We have port 1, port 2, port 3 and port 4. So based on the definition we can state what? So microwave circulator is multi-port waveguide junction which wave can flow from nth port to n plus 1 port. If n equal to 1, then n plus 1 is 2. So from 1 to 2, there is a flow of your microwave. Similarly, from 2 to 3, there is a flow of your microwave. Similarly, from 3 to 4, there is a propagation. But whereas in case of other case, 4 to 3, okay, or from 3 to 2 or from 3 to 1, it is not at all possible, and we will see how this is happening. Now let us consider the schematic diagram or 4-port circulator. Okay, in this 4-port circulator, so here we will have primary waveguide and secondary waveguide, right? Ports in primary waveguides are port 1 and port 2. Similarly, ports in your secondary waveguides are port 3 and port 4. Okay. Apart from this, you have two couplers, coupler 1 and coupler 2 between your primary waveguide and secondary waveguide. This coupler 1 and coupler 2 will introduce 90-degree phase shift. Okay, so your coupler 1 and coupler 2 will introduce 90-degree phase shift. If any of your waves will enter from port 1, right, through coupler 1 to port 3, or from primary waveguide to secondary waveguide through coupler 1, then it will have 90-degree phase shift. Similarly, okay, so when wave is try to enter from secondary waveguide to primary waveguide through coupler 2, so it will have again 90-degree phase shift. Okay, apart from this coupler, so here we will have a phase shifter in primary waveguide and secondary waveguide. So here the phase shift value is depend on the direction of flow. So if it flow from port 1 to port 2, in this direction it will have 180-degree phase shift, and backward direction from port 2 to port 3 it will have 90-degree phase shift in primary waveguide. Whereas in case of secondary waveguide, from port 3 to port 4 direction, it will have 0-degree phase shift. From port 4 to port 3 direction, it will have 90-degree phase shift. Now we will see how a wave can flow from port 1 to port 2. Okay, so let us consider a wave is fed into port 1, right? From wave is fed into port 1. So to reach port 2, it can take two paths. So one is direct path in primary waveguide itself, from directly from port 1 to port 2. When it travel here, so now what happens? It will have phase shift of 180-degree. So the wave reached at port 2 will have 180-degree phase shift when it flow in primary waveguide. The other way is nothing but what? So it can use coupler 1 and it can move to secondary waveguide. So then it can travels in secondary waveguide. Then it takes the path in coupler 2 to come back to primary waveguide. Okay, this is the path which it can take. So as we know, your couplers will introduce 90-degree phase shift. So now what happens when wave is fed into port 1, when it enter into coupler 1, it will have what? 90-degree phase shift. Okay, plus, so when it travels in a secondary waveguide, so here it is 0-degree phase shift. So no problem, here 0-degree phase shift, plus, so when it again enter into coupler 2, it will have 90-degree phase shift. So it will have 90-degree phase shift. Therefore 90-degree phase shift. Therefore, so the wave travels the path through secondary waveguide will also have 180-degree phase shift. Okay, therefore your output at port 2 will be in phase, because both are 180-degree phase shift, so they are in phase, so we will have output at port 2. Whereas if we considered, right, so we fed a wave in port 1, Now we will see what happens at port 4. Okay, so what happens? So now in the similar manner, right? Either it can take the direct path in primary waveguide through coupler 2, then it can reach port 4. Okay, or else it can take through coupler 1, then through your secondary waveguide to port 4. So now what happens? Let us see. When it travels in primary waveguide itself, it will have what? 180-degree phase shift. Okay, plus when it enter into coupler 2, it will have what? 90-degree phase shift. So totally the wave at port 2 will have 270-degree phase shift. Okay, so it will have 270-degree phase shift. Similarly, the wave enter through your coupler 1. So what happens? So when it enter through coupler 1 to secondary waveguide, it will have 90-degree phase shift. Okay, plus so from in secondary waveguide, it will have what? Only 0-degree phase shift. So need not to add anything. So it will have totally 90-degree phase shift to reach at port 4 through coupler 1. Okay, through coupler 2 it will have 270-degree phase shift. Therefore the wave at port 4 are 180-degree out of phase, so there won't be any power transmission between your port 1 to port 4. Similarly, you can consider about other case, right? Port we are applying input to port 1. What happens to port 3? Okay, so either it can take through coupler 1 to port 3, or it can travel up to coupler 2, then it enter to coupler 2, then it can come back. So for first path, what happens? So when it takes through coupler 1, it will have 90-degree phase shift. Okay, 90-degree phase shift, then it will reach at port 3. Okay, but if you see when it travels through when it couples through coupler 2, so what happens when it travels here in primary waveguide itself? It will have 180-degree phase shift. Then through coupler 2, it will have what? 90-degree phase shift. So 90-degree phase shift again. So when it moves from the reverse direction from the direction of port 4 to port 3, again it will have what? 90-degree phase shift. So it will have 90-degree phase shift. So total phase shift will be either 360 or 0-degree phase shift. So through coupler 1 it will have 90-degree phase shift, through coupler 2 it will have 0-degree phase shift again, but still both the waves are out of phase by 90-degree, so there won't be any power transmission between port 1 and port 3. Okay, so from this what we can conclude is when we give input to port 1, your output at port 2 are in phase. Therefore, we will have a power transmission between port 1 to port 2, whereas in case of if you give input to port 1, your output at port 3 and port 4 are out of phase, so there won't be any power transmission between from port 1 to port 3 or from port 1 to port 4. This is the reason why in case of circulator, where so here if you give input at port 4, we will get output only at port 1. Okay, if you give input to port 2, we will get output only at. So okay, let us write, right? So in case of S matrix, so we can write it as S11. So it is 4 port, S12, then S13, then S14. Okay, the second number represent your input, your first number represent your output. So if you give input to port 4, you will get output at port 1. It is represented. Other case you will not get an output. Okay, similarly, so here it is S21. That is, if you give input to port 1, you will get output at port 2. So we will have 1 here. Other case it is not at all available. Similarly here it is S32. Yes, 3, 2. That is, if you get input to nth port, we'll get output at n plus 1th port. Okay. Therefore, so if you give input to port 2, we'll get output at port 3. Similarly, if you give input at port 3, we will get output at port 4. This is an S matrix of your circulator.